In this example, we want to fill in any information that we can get from the diagram. So the diagram is going to be kind of like our given information, and if there's not enough information to provide an answer, we'll write not enough info. So let's take a look at the triangle on the right hand side, noticing that each one of these sides is congruent. So this will be an equilateral triangle. You could write equilateral, equiangular if you want, although automatically equilateral would mean that all three of those angle measures are equal. And if we think about it, there's only one angle measure that would be that would make that true. All three angles must be the same, but they must also add up to 180. And so that magic number, or what it has to be, is 60 degrees. So if angle A is 60, C is 60, B is 60, they're all the same and they all add up to 180. Can't be anything else. So we know right away that the measure of angle A is 60, the measure of angle B is 60, the measure of angle C is also 60. Now we could say the same thing about the sides, and actually if we looked, we see those congruent tick marks there. And AB here is 8 inches. You could abbreviate that if you wanted to, the unit. And then all three others, or all three sides, the other two, must be the same in length. That one's not too bad. I'm going to move down to this one here. We'll scoot that up just a touch. Alrighty. And we want to classify this triangle over here. So right away I'm seeing a few things. One, I'm seeing I've got some congruent tick marks here and here. So we know this one's going to be isosceles. We've got an obtuse angle here. So this one's going to be an obtuse isosceles triangle. And the measure of angle A here is 120. We know that the measure of these angles must be the same because the sides are congruent and the angles opposite those sides must be the same in a triangle. And so if we think about this, you can guess and check, or you can just take 120 away from 180, which is 60. But we want each one of these to be the same, and they need to add up to 60. So we could divide by 2, and then you would have 30 degrees. You could totally set up a mathematical equation for this. You could make this x or something, so it would be x plus 120 equals 180. That's perfectly fine. You could also reason through it kind of like we did here. So we know that angle C and angle B are going to be 30 degrees. You should verify that this adds up to 180, so if you want, you can put a little bar there and just add them up, or you can do it in your head too. 12 plus 3 is 15, so that's 150. 15 plus 3 is 18, and we're in the tens position here, so that is 180 degrees. And we know that they must be congruent, so we've met all of the requirements of the triangle. Notice how we have the same number of tick marks here, just 1 and 1. So this side will also be 4 centimeters. If we look at AB, AB is this one, so that's 4 centimeters, that line segment. BC is 7, stated in the diagram. And then we know that AC here is going to also be 4. Now we've got C and D here, so we've got a couple other examples to work, and then we'll be all finished with example 1. If we look at the classification of this triangle, and I hope that you can see this, the font is a little bit small. Anyway, so we've got, this shouldn't be here either, by the way. I don't think so. And so what we've got here is a triangle that has a right angle. One angle is 53. This is 3, and that's 4. Now, what we want to do here is we want to take a look at this. We know it's a right triangle. We want to try to find this other angle. If this other angle is the same as that one, then we've got a right isosceles. If it's not, then we know that the sides opposite angles that aren't congruent will not be congruent either. And so we don't know the other side here, but we do know if all three of these angles are different that it's going to be different. And so we could reason through this and make this a scalene triangle, or classify it as such. So let's take a look at this. We've got 90 degrees, so the other two angles in a right triangle are complementary. They must add up to 90. We would subtract 90 from 180, and that's 90, so 53, and this angle must add up to 90. If we take 90 and subtract 53 then, we'll wind up with this angle, and so that angle is 37 degrees. 37 degrees. Now, we can list those right now. We should probably do the classification of the triangle. So all three angles are different, meaning all three of the sides must be different. So this one's going to be a right scalene. And in the future, you will have a method to try to figure out AB. So for those of you thinking, what in the heck would I use for that? There is a very famous theorem and central to many parts of mathematics, and that is the Pythagorean theorem. So if you know that one, and you know how to use it, you can go ahead and use it. But that hasn't been introduced to us in class yet, and so we'll save that for a later date. Measure of angle A, that's 53. Measure of angle B, 37. And C here has the right angle symbol, so we know that the measure is 90 degrees. AB, remember we said we could figure that out later, or with a different formula or theorem. And so right now, though, we can write not enough info. BC is 4 yards. And then AC here is going to be 3 yards. And that's the best we can do right now. If we look at example D here, we'll take a look at this triangle, and this angle here is 45 degrees, and it's got one arc. This angle has one arc, and so the diagram is stating that these two angles are congruent, so we could even write 45 degrees right in there. Some people will put a tick mark. I think I've done that in past examples, like one tick mark there, one tick mark there. But if it just has the same number of arcs, then they are congruent, unless, like in this case up here on the top, if you put an arc there, you know, obviously it'd be 53 and 37, and those wouldn't be congruent. But if there's no angle measure, then if you have that one arc, then those two in the diagram would be congruent. So we know now that we have an isosceles triangle, actually, and the side opposite the 45 is 6, and this one's going to be 6 feet. And some of you are recognizing and understanding what angle A is going to be here. If we add 45 and 45, we get 90. We take 180 and subtract 90. That leaves us with 90. And so this is actually a right angle. You can use the right angle symbol, or if you prefer, you can do the arc with 90 degrees, but most often you're just going to see that right angle symbol written. Okay, so measure of angle A, we've got 90 degrees here. Measure of angle B, we've got 45 degrees. C is going to be the same. By the way, this is a right isosceles, so let's write that here before we forget. Right isosceles. AB is 6 feet. We know that BC then here, well, actually we don't know what that is. And again, if it's a right triangle, then you can use the Pythagorean theorem, and you'll learn that in a later class. So we'll write not enough info right there. And then AC then here would also be 6 feet.